right, so we are going to do another distance problem, and this one is a little bit more complicated than the first, but if you know the basic information from the first couple problems, you shouldn't have too much trouble with this. This is problem number 5. James has 2 toy trains, one colored red and one colored blue. The speed of the blue train is 7 inches per second faster than the one colored red. The trains start at the same point and travel in opposite directions. If after 3 seconds of travel, the trains are 39 inches apart, what is the distance each train travels in 1 second, and what is the speed of each train? And hopefully you realize that the distance each train travels in 1 second is the speed of each train. So let's go back to what we did with the first problem and just remember that if we know the speed is something is traveling and we multiply that speed by how long it travels, that will give us the distance. Then the next thing I want to do is draw a picture. Especially with these distance problems, it really helps to draw a picture. So we know that we have 2 trains. We have a red train and a blue train, and they start at the same place. So we're going to draw a place for them to start, and we have a red train and we have a blue train. All right. So we know they're going to travel in opposite directions. So the red train is going to go this way, and the blue train is going to go this way. And if you read a little further in the problem, it says that after 3 seconds of travel, so that means that each train is going to be traveling in the direction it's going for 3 seconds. So from the start, it goes 1 second, then it goes another second, which makes for 2 seconds, and then the final second. And the same thing's happening with the blue train. It goes for 1 second, then it goes for another second, and then it goes its 3rd second. So each second, the trains are getting further apart. And the problem says that after 3 seconds, the distance apart that these 2 trains are is 39 inches. So this whole distance is 39 inches. So if we know that each train goes for 3 seconds. If we knew how long the red train, or the speed of the red train, went for 3 seconds, and we added that to the speed that the blue train went for 3 seconds, we would get the total distance. So the distance that the red train travels plus the blue train, how its distance is going to equal the total distance, which is 39. So now we need to write an equation. So if we read the problem carefully, it lets us know how to write basically the speed of each train. It says that the speed of the blue train is 7 inches per second faster than the red train. So we are going to say that the speed of the red train is x. That's the one thing we do not know. We do not know the speed of the red train. We know that the speed of the blue train is however fast the red train is going, but 7 inches per second faster than that. So for the speed of the blue train, it's however fast the red is going, which is x, but then you have to add 7 inches per second. So the speed of our blue train is represented by x plus 7. So the red train is x, the blue train is x plus 7. Now we're going to add the speed of the red train, multiplied by the time the red train goes that speed. We're going to add that to the speed of the blue train multiplied by the time the blue train is traveling that speed. So the red train, right over here, is traveling at a speed of x. And we know that the red train goes for 3 seconds. So we would have to multiply its speed times 3 seconds. The blue train is traveling at x plus 7. But the blue train is traveling that speed for 3 seconds. And if both of the trains do that, the total distance they will go is 39 inches. So that's how we write an equation for this problem. Now, how do we solve it? Well, we want to put it on the balance scale. So I'm just going to bring this down a little. And on our balance, the first thing we're going to have is 3 of the x's, because x times 3 is 3x. So we have the 3 x's that represents our red train. And then we need to put 3 x plus 7's to represent our blue train. So x and a 7 cube, x and a 7 cube, and x and a 7 cube. This side represents the distance our red train travels because it's the speed multiplied by the time. And this represents the distance our blue train traveled because it's the blue train's speed multiplied by the length of time it goes that speed. And all of that together gives us 39 inches. The legal move we would want to do is to get so that there's only numbers on one side of the equation. So we can take 21 off of this side because 7 plus 7 plus 7 is 21. And if we take 21 off of one side, we have to take it off the other to keep our scale balanced. Adding 21 and then subtracting 21 gives you 0. So there's no number of cubes left on that side. All that's left are 6 x's. When we subtract 21 from 39, we get 18. So if 6 x's equal 18, x would equal 3. Now we have to know what x is. Yes, x is 3, but remember that x is the speed of our red train. So our red train is going 3 inches per second. To figure out the answer to the speed of the blue train, we just fill in our 3. 3, which is the speed of the red train, plus 7 is 10 inches per second. So our red train is going 3 inches per second, and our blue train is going 10 inches per second.